Dependency ratio helps you to understand labor participation within an economy. It helps you understand how the working population is growing within an economy. We'll understand the effect of dependency ratio on long-term economic growth and output per capital. Whenever I'm talking about long-term economic growth, it's more than 10 years and above. In this particular module, I'll be revisiting production function. We'll derive marginal product of labor. Based on base going down and Z going up, you will see the dependency ratio in the long term goes high. Reduction in working capital, which is X. When you take X and it's the working population, reduces the labor participation rate reduces. Less workers, less employees, you would say, in the workforce. If you see US, China and UK, they are pretty much very similar. According to the data by OECD, they describe a fertility rate as optimum as 2.1, which is stable, bit less than that. But nevertheless, if you see, Canada and Japan are much lower or lower than what you are comparing to the other countries. Happens. Now, it's very different when you compare Japan and Canada. Dependency age ratio should have been more. This is true for Japan. However, it is not true for Canada. So why? They have very similar fertility rates. They are very similar also in urbanization. Japan is a bit more urbanized. When looking at the difference between Canada and Japan, we come to know why is it? Because there are slight increase. If you look at, there's been a slight increase in China, there's been a slight increase in US and United Kingdom. Dependency ratio has come up a bit, but not much. What's very interesting is if you look at China, has very low dependency ratio. This is something which is very interesting. Look at the working age population. When you're looking at the working age population, one good example is Sweden. Sweden I took because it's very similar fertility rate. You're talking about this production function. We're talking about total factor productivity, which is given by level of technology, human capital, regulatory practices. Whenever we talk about the level of technology is how educated the human capital is. So there are a lot of variables which come in. It's very interesting. A country could be very huge, will have very high level of technology, also have a very good human capital, but since it's very huge, it will have a huge population which might not be as educated as the rest of the population. So that could also be one of the reasons why it drives down the factor A, which is known as the total factor of productivity. When we are going to be calculating a rate of change, when we are going to be deriving marginal product of labor or capital, you need to understand what is the rate of change. So whenever you're using a rate of change of any function, you're using differentiation. This is the differentiation function. Here you have a function which is a change in h, which is actually a small change. We are taking a limit which tends to 0. We'll come to this at a later date. Talking about f dash x is basically a derivative of the function f. So this is a good example. Why we are talking about this? Because we're going to be for marginal product of labor, I'm going